Hey guys, Mr. Mias is here and coming here tonight. It's not going to be a very long live stream tonight, but I am going to go over a few things with you for our unit review. And we're looking at inference on proportions. So I'll talk about kind of briefly over confidence intervals, one prop z tests, type 1, type 2 error, power, alpha levels, p-value, interpreting the p-value, and two prop z tests and sampling distributions, and then just some quick review of all the other stuff that we did to get you prepared for the exam. Excuse me. And if you have questions while this is going on, if you have questions, please, if you're one of my students, you can text me via Remind, or you can post it up on Google Classroom, and I will try to answer those questions as we go along. Now, before I get started, I do want to let you know that I do have another live stream that I did, I don't think last year, but the year before last. Actually, it might have been last year. So I have another live stream, though, on this unit where I do some other problems. So if you want to get some extra help, some extra explanations that I don't go over tonight, because this one's going to be a short one. I'm going to try to get done here by 8 o'clock. Then you can go to that one. Just search on it. It's Inference on Proportions Review, or one prop inference review, I think it is. So you can take a look, go on my YouTube channel and look for AP stats. All right, so let's go ahead and get started on a few things. Let's see if I can put this on here. Ooh, okay, let me get going here. My screen share. Ooh, infinite maestus. All right, so here we go. You should be able to see my screen here. So I'm going to talk about inference proportions review. So just a general review over everything that we've covered in this unit. So we've covered one prop, one proportion inference. Okay, so in one proportion inference, we've done confidence intervals. And sorry about my handwriting here. In fact, I'm going to take this and make it a little easier here. Myself. There we go. So we talked about confidence intervals, and we talked about hypothesis test, and we talked about type 1, type 2 error, power, and then we did two prop inference. So just a couple of key things that you're going to, oh, we also did sampling distributions. So sampling distributions. We did a problem like this. We did a sampling distribution problem in class today where we dealt with means and the sampling distribution for means. So let me just really quickly talk about sampling distributions, and then we'll get into confidence intervals and whatnot. Okay, so for sampling distributions, you are going to be looking for the word random sample. All right, so if you're looking for random sample, and you're also looking for normally distributed. All right, so if you see a problem in which it says normally distributed and you've taken a random sample, then you're going to do a sampling distribution. Now, if this is a free response question, you need your conditions. And then you need the mechanics to solve the probability. On this particular test, I'm just going to tell you there aren't any sampling distribution problems on the free response. So you don't really have to worry about the conditions. And we'll get back to the conditions for a sampling distribution for means in the next unit. But there will be one or two on the multiple choice. So here's what you're going to need to make sure you do.
I'm reminding you, time to clean up.
Alexa says it's time to clean up. Okay, so the proportions.
I'm reminding you.
Time to clean up. Okay, for proportions, our z-score is going to be p hat minus p over the square root of pq over n. All right, this right here, that part right there is your standard deviation, right? And n is your sample size, p hat. So you're going to find your z-score, and then you're going to find your probability of z being either less than or greater than whatever your z-score is based on your problem, your context problem. So we did a means problem today in class where you had it on your mid-unit exam, and this one you had a z-score of x bar minus mu over sigma over root n. And then the one we did on the mid-unit test, we had to do z is greater than, because it asked for more than what is the probability that we get a average more than 67. So we're going to want to take whatever our z-score is here and then find that. And the way we find this is we use normal CDF for this, right? And if we have a greater than symbol, then whatever our z-score is, that's going to be our lower bound. If we had a less than symbol, then that would be our upper bound, and our lower bound would be negative 999. In this case right here, our upper bound would have been positive 9999. Let me check if I have any questions right now. So yeah, like I said, Google Classroom, you can put a question up, or you can text me on Remind. Okay, I don't have any text messages. I don't even know if anybody's on this, to be honest. Okay. So I'm just going to keep going ahead. All right, so we went from sampling distributions to confidence intervals. And we did 2 confidence intervals. We did the 1 prop z. And in a 1 prop z interval, the formula for that was p hat plus or minus z star times the square root of p hat q hat over n. This part right here, just this part, that's called the standard error. This part that includes the z, that's called the margin of error. And this p hat right here, this is our sample proportion, or called the point estimate. So when we do a confidence interval, the goal here is for us to estimate what the true proportion is based on a sample. So we don't actually have a p. We're not comparing to a population proportion. We're just simply saying, okay, what is the interval that I think the true proportion is going to be in? Whenever we do something like this, we do need to state the conditions. So I'm just going to go and talk about the conditions for inference real quick. Condition 1 is that we had a random sample. When you state the first condition as a random sample, you need to say there's a random sample of females from Britain or something like that. You can't just say random sample. And never ever put SRS. That's wrong. Okay, don't do that. 2, we've got the less than 10% rule. And that one just states that our sample is less than 10% of our population. Okay, our sample is less than 10% of our population. We just want to make sure our sample isn't too big. And finally, the third condition, which is probably the most important in these, is that n p hat is greater than or equal to 10, and n q hat is greater than or equal to 10. Now, in a confidence interval, we're using hats because we don't know what p is. We don't know the true proportion. But in a hypothesis test, we're going to want these to be p and q based on our null hypothesis, which I'll get to when I get over hypothesis test in just a second. All right, so these are our 3 conditions for our 1 prop z interval. Make sure you know how to interpret that interval. We are 95% confident that the true proportion of females that have short hair is between 20% and 30%, something like that. Okay, and make sure you know how to interpret the confidence level. So what does it mean to be 95% confident? What that means is that if we were to do repeated samples, 95% of the confidence intervals that we create should contain the true proportion. Okay, so it's more about the percentage of confidence intervals that we create if we do this a bunch of times that will contain the true proportion. So that's what the confidence level means. What else about confidence intervals? You know, if we see a confidence interval, you know, we see this confidence interval. Let's say this is the true proportion. Let's say this line right here represents a true proportion. And I have a confidence interval here, and a confidence interval here, and a confidence interval here, and a confidence interval here, a confidence interval here, and then a confidence interval here. Notice this one's smaller. That just means I have a smaller margin of error. I possibly increased the sample size. So maybe that's how that happened. But notice that not all of the confidence intervals are going to be in the true proportion, and that's or going to contain what we believe is the true proportion. So that's what I mean by, you know, 95% confident or 99% confident. Now, if I created all these confidence intervals and, you know, only like 2 of them cross the true proportion, then, you know, I don't know if my confidence intervals are a very good indicator that something is going, that, you know, that we're going to capture the true proportion. So we can also use the confidence intervals to kind of tell us about whether or not we're actually doing a good job in capturing what's really going on. So that's just kind of an idea of confidence intervals. Oh, I had that on silent. Okay. So just so you know, my kids are starting to go to bed, clean up and everything. So I'm trying to be professional, but I'm at home and I'm doing this from home. So you're probably going to hear my kids start screaming and yelling and doing stuff because that's what they do when they go to bed. They just scream and yell. Anyway, so we had 1 prop z interval. That's the idea of 1 prop z intervals. Let's talk about 2 prop z interval. So in a 2 prop z interval, we're doing the same thing. We're trying to find a estimate something, but in this case, we're estimating a difference of proportions. All right, we're estimating the difference of proportions. Again, we're plus or minus z star. We're using the normal distribution. The square root of p hat 1, q hat 1 over n1 plus p2, q2 over n2. Now, these, by the way, q1 hat is really 1 minus p1 hat, right? We just subtract to find the other thing. These formulas right here are in your resource packet. So if you look in your resource packet in the formula sheet, the part that says inference, you'll see it says standard deviation of the statistic. These things right here are on there. So if you forget the standard error the formula for standard errors, just look in the resource packet. They are on there. You need to plug into your formulas to show your work. Now, if you just show your work and plug in the formula and then let the calculator do the work for you with the 2 prop z interval function, that's fine, just as long as you plugged into the formula and you've shown your work, okay? The conditions are the same, but do for both. So you're just going to do the same thing you did here, just for both samples. Okay? So, and that's pretty much all there is for confidence intervals. A lot of the stuff happens when we're talking about hypothesis test. All right, so let's talk about hypothesis test. Now, the hypotheses have 4 parts, right? We have hypothesis, conditions, mechanics, and conclusion. Now, if you want to be very special, you will make sure that if you do a complete hypothesis test, that your hypothesis test is in order: hypothesis, conditions, mechanics, conclusion. Okay, 1, 2, 3, 4, and not scattered about your paper. If you're organized, it's easier for the reader to understand what you're doing. So, you know, I would recommend you put, you know, number 1, hypothesis. Label it like that, and then go the null hypothesis. the alternative hypothesis, use dots here because you don't need an equal sign. P equals, I don't know, some number, 0.4, whatever comes up. P is greater than 0.4, you know, whatever. And then you say P is the proportion of females with short hair. All right, this is a nicely formatted, now granted my handwriting isn't great, but this is a nicely formatted hypothesis test. Okay, it's clear what you're doing, it's clear where P is, it's clear what P is, what P stands for, the proportion of females with short hair. And then you label number 2 and you write your conditions. There will be plenty of room on your test to do this. And you say number 1, you know, a random sample of females. Okay, so you want to write these out as nicely as possible. That's less than 2% of all females. Okay, make sure you include context. 3, you're going to want to put NP. In this case, NP would be N. Let's just say N is like, I don't know. Let's just say the N is like 200. So then you're going to go 200 times 0.4, and you're going to say, is that greater than or equal to 10? And Q, so that's going to be 200 times 0.6, greater than or equal to 10. And then you do your conditions. Now you got your conditions done. Now you go to step 3, and that's mechanics. Okay, make it look nice. Make it look organized. Don't have like your conditions over here on the side scratched out, and then your don't put your hypothesis down here next to your conclusion. I really dislike that. I have seen it on the AP exam when I've done AP reading, and it's just, it is quite annoying. If you put it in order, it's very nice, easy to read, and you won't miss points. Now, if you don't know your conditions, you do hypothesis, you don't remember your conditions, so you leave that blank, which could do your mechanics or conclusion, then it's still easier for us to follow, and you might not get the points for the conclusion, but at least you pick up the 3 points for the stuff you did know how to do. All right, so for in a hypothesis test, just so you know, right now I'm doing a 1 prop Z test. Now, if you were an AP student and your teacher said, look, right here, you need to tell me what test you're using, then I'd identify the test. So I'd say I'm using a 1 prop Z test. Z test, zest, Z test, okay? Use a 1 prop Z test. So some teachers and professors, they make sure that you write down what test you're using. However, in the AP exam, this is what I tell my students, I want to see your Z score. So Z for a 1 prop Z test is P hat minus P over the square root of PQ over N. Now notice again, we're using PQ and not P hat. Over here on the confidence intervals, I used P hat and Q hat. So I would use P hat, let's just say P hat from our problem was 0.42. So then I'd go 0.42 minus 0.40 over the square root of 0.40 times 0.60 over N was 200. Now, notice I only use P hat once, right there, right here, and right here. Okay, right there is the only place I use P hat. Everywhere else, I used P. Okay, so then I calculate the Z-score. And I actually do not have a calculator with me to calculate this bad boy. Let's get one out real quick. I think it'd be good just to go through the paces here for this one problem to make sure you get all of the things that, all the important pieces that you want to put on this, okay? How do you know whether or not this is a hypothesis test? Well, you'll see the word evidence. Anytime you see the word evidence, that's a hypothesis test. All right, that's going to take a while to come up here. Do I have any viewers at all? Infinite meiosis. Doesn't look like it. Oh well. Hopefully you guys will view it at some point. I don't even know if I'm helping you guys. Okay. Where is my Calculator. Jeez. Why did that take so long to come up? All right, so what we're doing here. We got 0.42 minus 0.40 over the square root of, oops, I want that one, 0.4 times 0.6 divided by 200, 0.577, all right, 0.577, that's my z-score. So then I'm going to do the probability that z, and I'm going to take this number there, put it there, 0.577, and I'm going to use a normal CDF. Let's do that. Menu, statistics, distributions, normal CDF. My lower bound is going to be 0.577 because it's a greater than sign. So then I need my upper bound to be 9. Somebody asked me earlier today, like, how many 9s do I know to use? Do I use 1? Do I use 2? Do I use 3? I'd say just use like 6. Why not? More the merrier. 0.28. Okay, so 0.28. So this is your p-value right there. Now, if I did this on my calculator, menu, statistics, stat test, one prop z test, my p0 is 0.4. I would actually need to know the number of successes. So I would need to know 42 out of 200 is 84. So this is 84, tab 200. And then I have to decide it's going to be greater than. Now, see, notice here the p-value right here is 0.28 and my z-score is 0.57. So I can just plug in right here. I can plug in all the stuff I need right here. And then I can just say that's equal to 0.577 because it's sort of calculated in my calculator. And then I can just write p-value equals 0.28. I don't have to write this part right. I don't have to write this part right here. I can just write p-value equals 0.28 and I'll be okay. That'll be good for showing your work. All right, that's the most important thing. All right, so let's assume that we have an alpha level of 0.05. Then we're going to do our conclusion. And our conclusion is, since our p-value of 0.28 is greater than the alpha level of 0.05, we fail to reject the null. It seems like my students are really getting understanding when to fail to reject and when to reject the null, which I'm happy about. And then we're going to say there is no evidence or not enough evidence or insufficient evidence that the proportion of females with short hair is greater than 40%. Now, where did I get this information from? That was my alternative hypothesis, okay? All right, so that's a complete hypothesis test. It should look like that. Please, if you watch this video, please have your hypothesis test look like this, okay? There's one on the test. You got to make sure you know how to do that, all right? Now, let's just talk about a few things about this hypothesis test that sums up kind of a lot of stuff that we're talking about in this unit. So first of all, how do we interpret what this p-value represents? Well, what this p-value represents is if the null hypothesis is true. So if, in fact, the proportion of females with short hair was 40%, then we would see samples that occurred of 200, samples of 200. So if I continue to take random samples of 200, I would see samples that had 42% with females with short hair. I would see that about 28% of the time. If the null hypothesis were true, that's a pretty high percentage. That means, yeah, it's going to happen, right? It's 28% is actually a pretty high percent that I would see. So what we're really looking at is the p-value is the probability of getting what I get in my sample if the null hypothesis were true. That's why if my p-value is very, very small, you know, like 0.5%, then I would say, you know, there's only a 1 in 200 chance. What's that? 0.5%? That's half of two. There's like a 1 in 200 chance. All right, a 1 in 200 chance that I would get a sample like I did if the null hypothesis were true. That's so minute that the null hypothesis can't possibly be true. That's why I'm going to accept the alternative. Okay, so that's why when our p-value is so small, we would do that. So understand what the p-value represents in context. So if I was to write this out, so if this was to happen to me, and I got this, and I said, write this in context, I would say that the probability of getting 42% of women with female the probability of getting 42% of females with short hair in samples of sample size 200, if the true proportion of women with short hair is 40%, the probability of that occurring is 28%. All right. Okay. Thank you for that information, Brandon. Can't listen to YouTube while sending messages unless you have YouTube Premium. Ooh, YouTube Premium. Anybody have YouTube Premium? I'm not gonna pay for that. Okay. Although, you know, I could. I don't know. I don't want to mess on YouTube because I'm on YouTube right now. So, you know, get YouTube Premium. Advertisement for YouTube. Okay, so that's the p-value. Let's talk about type 1 and type 2 errors while I'm here, and then I'm going to talk about the two prob z tests, and then I'm going to be done. So type 1 and type 2 errors. So again, we're talking about the proportion of females with short hair. I don't know why I picked that as my context, but that is. If I have a type, what's the level of confidence again? Okay, I'll go back up there and I'll answer that question in just a second. So if I have a type 1 error is when we reject the null hypothesis when we should have done the opposite, okay? And a type 2 error is when I failed to reject the null hypothesis when I should have rejected the null hypothesis. So you really want to make sure that when you study that over again, and I really don't have time to go through type 1 and type 2 errors too much. Actually, on my other video, I do spend more time writing out type 1 and type 2 errors. So I would suggest going to my other video and finding when I talk about that. I can tell you this. Type 1 error, the probability of getting a type 1 error is alpha. That's where we get this alpha level from. The probability of getting a type 2 error is beta, and power is 1 minus beta. So power is actually the probability of not getting a type 2 error. So power and type 2 error are closely associated together. Whenever type 1 error goes up, type 2 error goes down, and vice versa. You can reduce both type 1 and type 2 errors by increasing the sample size. All right, which would also increase your power. If you reduce type 2 error, you increase power. So that's how they're all connected. So again, you will be asked to identify which type of error you did. So if you rejected the null, then that means you could have done a type 1 error. If you failed to reject the null, then you could have done a type 2 error. Okay, so just remember 2 goes with fail to reject the null. Okay, so let me quickly talk. I know Let's just somebody just asked me about confidence again. What is confidence level? So let's say I'm doing 95% confidence level. That means that 95% of confidence intervals of sample size n should contain the true proportion. So again, if I get sample sizes of whatever sample size I got, and I do this again and again and again and again, I create multiple confidence intervals, 95% of those confidence intervals should contain the true proportion. Okay, that's what confidence level means. Okay, last thing I want to talk about here is your two-sample hypothesis test. You guys have been doing a lot of stuff on two samples hypothesis tests. So just a couple things to remember. Two prop tests and two prop intervals. So in a two prop test, your null is always going to be a P1 equals a P2. All right, remember that's always an equal. Remember that here and here you want to use context subscripts. Okay, that's not subscripts. And then your alternative is going to be either greater than, less than, or not equal to. Now, if you have a not equal to, that's a two-tailed test. So you're always going to multiply by 2 for your p-value. That's, of course, if you're doing it by hand. If you're doing it using the calculator and you're letting the calculator do your two prop z test, then you're just going to choose not equal to, and it's going to do what it does. A greater and less than, that's a one-tailed test. Okay, somebody asked that. That's how you do it. Your conditions are the same, just for two. With a two prop test, you'll need to do the pooled proportion and use the pooled proportion, PC, which is x1 plus x2 over n1 plus n2. You'll need to use these, the pooled proportion, for your standard deviation. Now, your z-score for that's going to be p1 hat minus p2 hat over minus 0 over the square root of PC QC over N1 plus PC QC over N2. And I've had this on the board for a week now, so you need to put this somewhere so that you can remember it. You know what I mean? Put it somewhere where you can remember it. Lastly, if you get in a two prop z test, or an interval, okay, if you get a confident, can you use a good sentence frame for the conclusion on a z test? Yes. Oh, for a one prop z test, actually, it's always the same, guys. It's always this. Since our p-value of blah, blah is greater than blah, blah, our alpha level, we fail to reject or don't fail to reject Okay, I'm not quite sure I understand what is 1 times 1 or times 2. So can you rephrase that so I can understand that? We fail to reject, or we reject the null. There is no evidence, or there is evidence, depending on whether your p-value is small or large, that and then you repeat right here is just the alternative hypothesis in context. All right, I do believe that I gave you this sentence frame for the conclusion. The conclusion is the same for one prop z test, for two prop z test, for t-test when we get to t. In fact, this conclusion remains the same for the whole thing all the way through. Let me give you, though, the confidence interval for a two prop confidence interval. So let's say we had something like negative 0.03 to 0.12. So what we're saying here, and let's say P1 represented the proportion of females with short hair, And P2 represents the proportion of oh, what's X1 and X2? Sorry, I understand you now. Okay, this is your number of successes in group 1. And this is the number of successes in group 2. So like, let's say proportion of females with short hair, proportion of males with long hair. Okay. So X1 would be the number of females with short hair in my sample, and X2 would be the number of males with long hair in my sample. Hopefully that made sense for X1 and X2. Thank you for rephrasing that. Okay, so back to the confidence interval for 2 proportion. If I have a negative and a positive, then that means 0 is in here. So what that tells me is that the null hypothesis could possibly be true. So I would have to, if it goes from negative to positive, I would fail to reject the null if I was just looking at the confidence interval. But let me interpret this confidence interval for you. So this is 90%. We are 90% confident that the true proportion of, okay, so I'm going to assume that for this problem here, I did P1 hat minus P2 hat. So this is PF hat minus PM hat. Okay, so so I would start with the first one. So when I'm doing this, whatever my first proportion was, that's what I'm going to start with. So we're 90% confident that the true proportion of females with short hair. My daughter is so cute right now. She's whispering. With short hair is between 3%, okay, converted into a percentage, lower, because it's negative, and 12% higher because it's positive than the proportion of males with, looks like we're comparing them with long hair. Okay. So since it's between 3% lower and 12% higher, they might even be the same. So I would fail to reject the null. I'd only reject the null if it was all positive or all negative. And that's how we use confidence intervals with 2 proportions to talk about hypothesis tests. Okay, so it's 8:08. I'll go ahead and answer some questions for those that there were still some questions that were asked. Thank you for contacting me via Remind. That was very helpful. It's much easier for me to get those. Really quickly, just to give you some insight. Somebody did ask also, how will we know what to use in terms of alpha level? So alpha level is always going to be 0.05 unless said otherwise. So yes, if I give you an alpha level of 0.1, or I say if the significance level is 0.1, then you would do that. The only other issue would be if I gave you a confidence interval and I asked you to use the alpha level based on the confidence interval. And in that case, you need to know if it's one-tailed or two-tailed, and then you just go to your t-table and you look at your t-table just like we did before. So you go to your confidence level and you just go all the way straight up, and all the way straight up will show you where your what that will be, what your alpha level will be. What was I going to say? In terms of all the other stuff that's on the test, you should definitely just kind of look over being able to describe symmetry, know what values. Let me go back to here. All right, hey guys. So make sure you know what values to. I'm just checking my beard out. See, this is a nice beard. What values that you can. I'm sorry. What measures of center and spread that you're going to use based on whether the distribution is symmetric or skewed. Make sure you can compare values, like or compare whether something is skewed left and skewed right, whether you need to use the whether the mean is higher or the median is higher. So be able to read a 5-number summary, right, and be able to maybe understand, like, okay, if the mean is greater than the median, is this going to be skewed left or skewed right? And more importantly, if there are any outliers, how does that change the skewness? Okay, and how far away is the first quartile from the mean, and the second quartile from the mean or the median, and can that tell you if things are skewed left or skewed right or symmetric? So you're going to need to be able to decide whether something is what the shape of the distribution is based on some statistics and a few of the data values. Okay, make sure you know how to find outliers. We've gone over this so many times, how to find outliers. Make sure you know how to find outliers and describe those. Decide whether something is an observation study and an experiment. Remember, when you do that, you must say why something is not an experiment and why it is, if it isn't, and why, basically you need to say why it is or it isn't. And if you say it's an observational study because there's no treatments, you have to describe the treatments. If it is an experiment, then you have to describe the treatment, okay? So you can't just say this is an experiment because treatments were imposed. You have to say what treatments were imposed if it was an experiment. So you have to make sure you're detailed on that. Know how to determine the difference between a simple random sample, a systematic, a stratified, and a cluster sample, and multi-stage. Gosh, there's just so much we've done, right? There's so much. I'm trying to give you some hints to make sure that you know these. Make sure you know how to do that sampling distribution problem like we did in class today. Make sure you know how to read computer output. It's so easy. Make sure you just go and glance back over it again, because one of the problems on there, there's always going to be problems on there that have you read the computer output. As long as you identify that slope and that intercept in the right way, write your linear regression in context, and then be able to describe your slope. I've given you sentence frames for that. Describe R squared in context. I've given you sentence frames for that. Describe y-intercept in context. I've given you sentence frames for that. Be able to use that that linear regression model to find a residual value or to find a prediction. Okay, there's a lot. I mean, there's a lot to do there, but you need to make sure that you kind of go over that stuff. Just glance over it. I know you've been doing it, and some of the stuff you haven't looked at before, but believe me, all you gotta do is glance over your notes on those, and it'll come back to you really quickly, because we did so much of that and so much of that and so much of that. I think I kind of burned some of that in your brain. STD, right? Shape. I'm sorry, not shape. Strength, type, and direction. All right. Cuss, center, unusual features, shape, and spread. Any questions before I leave you tonight? I go change it to my pajamas finally. Okay. Doesn't seem like it. Okay, guys, if you need some more, please go ahead and go to my other video. And how do we know what confidence interval to use? I will tell you. Okay, I will tell you what confidence interval. Okay. AP stats, baby. AP stats, baby. Okay. Good luck, guys. We'll see many of you tomorrow. If you're not in my class and you're in this Figueroa's class, good luck. And if you're not in any of our classes and you're just here from another place, good luck on your test too. If you're having trouble with inference on proportions. We'll see you later, guys. Bye.